Okay, in today's section we're going to talk about zero and negative integral exponents. In the last video we looked at algebraic expressions involving exponents. In this section we're going to do the same thing. The only difference is these exponents are going to either be zero or they're going to be a negative number. So really this entire section boils down to two things, and if you can remember these two things it's going to be easy as cake. And I'm going to go ahead and write them up here in the upper right hand corner and leave them there as we work these problems. The first thing is x raised to the 0 power is by definition 1. That is a universal truth. It's absolutely true, and it's always going to be true. Now x here can be anything. X could be 1, so 1 to the 0 is 1. X could be 59, 59 to the 0 is 1. X could be some massive expression in parentheses and the whole thing raised to the 0 power. By definition, anything raised to the 0 power is 1. The second thing is I'm just going to pick a different variable to be cute. Let's say y raised to the negative x, where y is some number and x is some number, is the same thing as 1 over y to the x. These are two things that I'm going to leave up here on the board, and we're going to leave them there to stare at us right in the face during the course. The only thing you have to remember, anything raised to the 0 power is 1, and if you take anything and you raise it to a negative power, that's the same thing as taking 1 and dividing by that letter to the power. Okay, so let's just go through some examples, and this is going to be just really simple. This is the most general case. Let's get to some real examples. Let's say I have something like 2 to the 5th times 2 to the minus 2. Okay, I want to simplify this, and I want to simplify each of these expressions without using any parentheses, and I don't want to use any negative exponents. Well, let's go ahead and use these rules. First of all, 2 to the 5th, nothing changes there, so I'm just going to write that down, 2 to the 5th. Now I've got an exponent, something raised to a negative power. So I'm going to just say this is equal to 1 over 2 squared. Look at this and look at this. 2 raised to the negative 2 is the same as 1 over 2 raised to that power. So all you do is strip the negative out and do 1 over it, and that's it. And this is absolutely true. If you were to take 2 and then put it in your calculator and raise it to the negative 2 power and get that number, it would be the same thing as 1 over 2 to the 2. Just like that. Now, further, if I want to simplify this, this is simply, this is really a fraction. 2 over 5 is the same as 2 over 5 over 1, 2 to the 5th over 1. So this is really 2 to the 5th over 2 to the 2nd. And we can reduce this fraction because I have essentially, and I'm going to do this blown out in the first example to make it clear. On the top I have 2 times 2 times 2 times 2 times 2, that's 2 to the 5th, over on the bottom I have 2 times 2. Now in fractions like this, when I have lots of things multiplied together, anything on the top can cancel with the same thing on the bottom, because I've got 2 over 2, that's 1. I cancel this 2 with this 2, that's 1. So on the bottom I'm just simply left with 1, and on the top I'm left with 2 times 2 times 2, which is 2 to the 3rd. That's the long and drawn out way to simplify this. I do not expect and I do not recommend you to simplify the expressions by writing it out. What you can simply do is look at this and realize that I have 2 to the 5th on top, 2 to the 2 on the bottom, and I can simply subtract these two. 5 minus 2 is 3, so the answer is going to be 2 to the 3. Another way to do it is just looking at this. I've got 2 2's in the bottom and I've got 5 2's in the top, so I can cancel this 2, and 5 minus 2 is 3, so I can write a little 3 up there to remind me, and so the answer is just going to be 2 to the 3. We're going to do so many of these, this is going to seem old hat, so let's just keep on going. Let's say I have 3 to the 5th, okay, times 3 to the minus 2 over 3 cubed. Okay? Well, let's go ahead and take care of our negative thing first. So I'm going to have 3 to the 5th on the top. I'm going to move this quantity down to the bottom. How do I do that? Well, I've got to keep the 3 to the 3 intact, but I'm going to move this down and make it a 3 squared. All I did was I moved it downstairs and I took the sign off. So all you do is take the sign, you move it downstairs, okay? So then on the top I've got 3 to the 5th, and on the bottom I've got the same base, so I can simply add these exponents. So I've got 3 to the 5th, okay? 3 to the 5th over 3 to the 5th is simply 1. Anything divided by itself is 1. Another way to simplify this is just an alternative way, is to say, okay, I've got 5 here and I've got 5 here, so this is going to be 3. 5 minus 5 is 0, because I can subtract the top exponent from the bottom exponent because they have the same base, and anything to the 0 power is 1. So one way to look at it is I've got the same thing on the top and the same thing over bottom, so it's like 2 over 2 or 5 over 5 or 10 over 10 or whatever. I can divide anything by itself and I can get 1. Or I can do it the exponent way and say I'm going to simplify this by just taking 5 minus 5 gives me 0, and then anything to the 0 power, following the first rule, gives me a 1 by definition. So we're going to be using some skills today that we've developed in previous lectures. Namely, we're going to be figuring out how to simplify fractions. The only real difference being that we're going to be simplifying algebraic expressions. The only real difference is some of these exponents are going to have negative numbers in there. So let's take another one. 2 to the 5th times 2 to the 7th over 2 to the 6th times 2 to the negative 3. Now, my job is to teach you how to work a variety of problems, and I'm going to try to teach you to do different problems different ways. So, in the previous two problems, we've moved the negative, upstairs. Okay, but I'm going to mix it up a little bit, and I'm going to show you a couple different ways first. I don't have to deal with this negative first. I could, but I don't have to. I'm going to choose to deal with this over here. I've got 2 to the 6 on bottom, and I've got this junk on the top. Well, I can cancel this out and strike the 7 and just put a 1 up here, because 7 minus 6 is 1. I have the same base on the top as I do on the bottom, and 7 minus 6 is 1. So I can basically divide. What you're doing here when you do this is you're dividing the top by the bottom by the top and the bottom by 2 to the 6th power. 2 to the 6 divided by 2 to the 6 is simply 1. That's why it disappears. And on the top, 2 to the 7 divided by 2 to the 6. 7 minus 6 is going to give me 1. So if I were to rewrite this, I would have 2 to the 5 times 2 to the 1, okay, over 2 to the negative 3. That is what happens when I start to cancel these things. Basically, you look for commonality of things in the top and the bottom. I have 2 raised to something in the top, 2 raised to something in the bottom, and I can just simply subtract those exponents and arrive at the simplified thing, which is right there. So how would I continue to simplify this? And we have this negative exponent, okay? Well, this thing works in reverse, okay? I can move this upstairs, so I can say I have 2 to the 5th times 2 to the 1 times, and I can move this thing upstairs by saying 2 to the 3rd. Basically, with these negative exponents, you can move them up and down all you want. It's just that when you move it upstairs, you've got to make the negative exponent, you've got to change it into a positive exponent, and if the negative exponent's up here, when you move it down, you've got to make it a positive exponent. So all I did was I moved this upstairs and I changed this to a positive number. Okay? Now I can simplify this whole thing because I've got an exponent with the same base. So our rule for exponents from the previous lesson is I can simply add the exponents. So 5 plus 1 is 6, 6 plus 3 is 9. And that's 2 to the 9th power. And that's the answer. Okay, let's say I have 2, this is mixing it up a little bit different, 2 times x to the 0 power. Well, that's going to be 2, and x to the 0 is 1, by definition is 1, so this is going to be times 1. So the answer here is simply 2, because this x to the 0, another way to write this is draw an arrow through it and just put a 1 there, just to remind yourself that that whole term goes to 1. 2 times 1 is 2. So that's that. Okay. So it's not that bad. And if you want to get a little bit more fancy, I mean, just to show you the extent of this, what if I have something like a squared b to the third over a b to the fourth, something like this, all raised to the 0 power. Again, the entire thing is raised to the 0 power, so that's just going to equal a big fat 1. No matter what goes in here, it could be huge, but if the entire thing is raised to 0 power, the end result is going to be 1. That's just a mathematical definition. That's kind of like saying 3 is greater than 2. I mean, that is just a definition. How do you know 3 is greater than 2? Well, somewhere someone decided that that was just going to be the way it was, and they were going to develop math, based on those assumptions. Well, somewhere someone decided that anything raised to the 0 power was going to be 1, and that's just the way it's going to be. Okay, so what if I have something like x to the negative 2? How does that go? Well, by definition, you see, I can move it up or downstairs as long as I change the sign. So I'm going to choose to move this downstairs, and so x to the minus 2 is going to simply be equal to 1 over x squared. So you can move them up, because remember, there's an implied divided by 1 here. Any number, there's an implied divided by 1, so I can choose to move it downstairs and change the sign of the exponent. There's no problem there. Now, my job is to show you what's legal in algebra. Your job is to figure out if you should do it or not. Let's say I have 2y raised to the negative 4th power. Well, I've got some quantity raised to a negative power. It's currently upstairs because there's an implied divided by 1 here. So I can simply make this equal to 1 over 2y to the positive 4th power, and I can move it downstairs and make that positive. And I could just leave this as the answer, but I'm going to go ahead and simplify it just a little bit more, because remember, if I have, from the previous video, if I have two things and the product of them are raised to the power, I can simply write that as 2 to the 4th y to the 4th, and you can look in the previous video for that. So that is the full-blown simplification of this. Okay. Now, what if I have something like y to the 4th over y to the 5th? Okay. Well, I've got 4 y's on the top, y times y times y times y, and on the bottom I've got 5 y's. 5 y's. Y times y times y times y times y. So I've got extra number of y's on the bottom. I've got 4 on the top and 5 on the bottom, so I can cancel all 4 of them on the top, and I can cancel all but 1 on the bottom. So the answer is going to be 1 over y to the 1st power, which is simply 1 over y. Basically, if you have exponents on the top and the bottom, you just look at the exponent, okay? Whichever one's bigger, which in this case the bottom one's bigger, he's going to be the one that's going to win out. And all you do is subtract them to figure out what the exponent is. Okay? If the y to the 5th were up here and the y to the 4th were down here, it'd be y over 1. But because y to the 5th is bigger, then he wins out and the y stays on the bottom, and so I subtract the 2, and it's just going to be like that. You can kind of think of it as, y times y times y times y, and on the bottom I've got y times y times y times y times y. Well, I can cancel all of these with all of these, so I'm left with 1 over y. That's the long way to do it. Okay? The short way is you just look at the numbers. Whichever one's bigger, he's going to have y, and to figure out what the exponent is, you just subtract the 2. And like I say, we're going to do a whole lot more of these to make that concept clear. That can be confusing, but it's really not that bad, and we're going to work through a whole lot of these things to make it a whole lot more